Hello and welcome back to Calculus 1 section 5.4 on a couple of formulas that we need to know. We don't need to know. These are the quality of life formulas. If you know them later on in mathematics, say some 300, 400 level math course, you get to skip a whole page of calculations if this applies, which is awesome. We are not going to use any of these formulas extensively in Calc 2, Calc 3. So your life doesn't depend on these. It's just one of those cool things that you can, use. So before we go with the formulas, I just need to remind you of what it means for a function to be even and for a function to be odd, right? So in mathematics, odd function has the property that f of negative x is equal to negative f of x. So for odd function, this is what holds. So odd function would be any function that has only negative exponents, if you're talking about the polynomial. Other odd functions that you know should be sine and tangent function. So what is in a bag? In a bag is polynomials with only odd exponents. And number two, sine x and tangent x. So these are your odd functions. And there is a test for it, right, to use. So let's say if f of x is given as x to the 5 minus 4x cubed plus 6x. You will construct f of negative x, which is negative x to the 5 minus 4 negative x cubed plus 6 times negative x. And you will work out this algebra. So this will become negative x to the 5. Minus and minus will give you a plus 4x cubed. And then plus and minus will give you minus of 6x. And now, when you factor out negative sign, you are left with x to the 5 minus 4x cubed plus 6x, which was original function, meaning there is negative f of x. So you got through this calculation that f of negative x is equal to negative f of x, and this is good enough proof for us to say that this function is odd. Next creature is even function. And for even function, we have f of negative x is equal to actual f of x, right? So this would be the group of functions that have this property would be the polynomials with only even exponents, and I'll put and constants. Cosine x and secant x are even. The other ones as well, but these ones are actually the ones that are useful. So if you have a function f of x equal 2x squared plus 9, and you construct f of negative x, which is where you replace your x with negative x, once you apply a square, it's just going to kill the negative. And you got f of x back. So this particular function is even. You are allowed to have any polynomial term with even exponent and constants, like 9. You can also have pi or whatever, but constants don't change, obviously. So that's the review from pre-calculus 1 about even and odd functions, because we need those for the first two calculus formulas. These are not major results, so I'm just going to keep it blue. So now we have integral negative a to a of f of x dx equals 0. And now in blood, odd. So if the function is odd and you have symmetric interval, that means negative 3 to 3 or negative 1 to 1. So it's important to have the same, right, negative a, positive a. You must have same numbers there, with one being positive, one being negative. And odd function, result is 0. So that immediately means that if you calculate negative pi to pi for sine x dx, answer is 0 without calculating. If you are calculating negative 9 to 9 of x cubed plus 6x dx, answer is immediately 0. No calculating. Now, you can go and compute and verify all of this, right? But we have a theorem up there which states that rule. So if you have odd function on the symmetric interval, the answer for that integral is 0. All right, the next one is obviously for even functions. So number 2, we still have negative a to a, and now we have f of x dx, but this time around f of x is even. We are going to get 2 times the integral 0 to a of f of x dx. So it's not a huge time saver, but at least you don't have to compute, at negative 9 or negative 3. You can compute at 0. It's much easier to multiply by 2 than to compute the whole antiderivative with a negative number of some sort. So, it shaves off a couple of seconds, right, off your work. Just like when you have a Case 2 beacon, right, but you already have the efficiency 5 pickaxe, so, it doesn't really help, but, you can set it up. Yeah. Great. So, this one would be used this way. So let's say you want to integrate cosine 3x from negative pi over 3 to pi over 3. Right, let's say you want to compute this. So, dx at the end, oops. So this is even function, so you have 2 integral 0 to pi over 3 cosine 3x dx. And now the integral is cosine goes into a sine, so we have sine 3x over 3. You have to remember that over 3 there. There is a 2 in front, which is a constant you copy. And then you are computing from 0 to pi over 3. Pi over 3 is a terrible. I'm moving this to, should we do pi over 6 or pi over 4? Pi over 3 is bad. Pi over 4 or pi over 6? Quickly. 6 it is. I heard 6 first. Change them all to 6. Pi over 6, pi over 6, pi over 6. There we go. Great. So this becomes now, right, it's easier to compute at 0. That's why we did all of this. So we have 2/3 in front. And now you have sine of 3 pi over 6, which is pi over 2, minus sine of 0. Well, that's 0. So I have 2/3 sine of pi over 2. Sine of pi over 2 is 1. So the whole thing is 2/3. I did not have to compute at negative pi over 6 as well. So that's where the shorter calculation is. Right? It just helps a little bit. Right? A little bit. Helps a little bit. And this leaves us with the last formula to cover. And that formula is the formula for the average value using integrals, the average value of the function. So the function will take on average value of f of x. So if you have some function f of x on the interval a to b, there is going to be an average value somewhere. An average value. So how do you calculate average value of the function? Here's the formula. Average value f bar of the function is calculated as 1 over b minus a of the integral ab f of x dx. That's it. Now this is a cool result because we can do things here. You know, they calculate the average rainfall for a month, the average rainfall in a year, right? So to calculate average anything, right, you will be using the integral and then multiplying it by 1 over b minus a. So one of my project problems at some point in life for Calc1, I mean, I still have it, is the rainfall problem I did mention last time. And you have to use this formula to work it out. Now, this result can be rewritten as the mean value theorem for integrals, because average, mean, right? So you can actually calculate the value c. So that's average, and that's going to drop that value c. So f of c is equal to the average value of f, which is 1 over b minus a, f of a, b, f of x dx. So you can compute the value of c for which you get the average value of the function. It's the same formula, it's just an extra step for you to calculate. Let's actually say, oh, I'm gonna give this a name. Mean value theorem for integrals. Find c using mean value theorem for integrals. You can't pronounce this, but you all know what it means. For f of x equals something. Did someone said e? Okay. E to the 2x on 0 to, let's make it easy, ln 5. I am. So our f bar is equal to f of c is equal to 1 over ln 5 minus 0 integral 0 to ln 5 e to the 2x dx. So f of c is e to the 2c is equal to 1 over ln 5 integral of e to the 2x. Well, let's just write one more time and then we'll do the integral dx. So this is an equation and the only unknown is the c. So e to the 2c is equal to 1 over ln 5, and now I have here integral of e to the 2x is e to the 2x divided by 2 computed from 0 to 5. Ln 5. Ln 5. So e to the 2c is equal to 1 over 2 ln 5. And over here I have e to the 2 ln 5 minus e to the 0. E to the 2c is equal to 1 over 2 ln 5. And now the 2 will go in as a square. So that's a 25. And then e and ln cancel. So this becomes 25 minus 1. Now I'm going to actually do this calculation on the side by saying e to the ln 5 squared, which is e ln 25, which is 25.
It's too much.
Yeah, 25. There we go. So this works out to be 24, cancelled by 2 is 12, so e to the 2c is equal to 12 over ln 5. So now to get your c, you ln both sides, and you get that 2c is equal to ln of 12 over ln 5, and finally c is equal to 1/2 ln 12 over ln 5. Now you can just punch this in a calculator and get a decimal for it, but you have your c. So at this c, you have the average value of the function on 0 to ln 5. Cool. As you can see, calculation is the same, except now you're not doing the f of b minus f of a divided by b minus a, you are doing the integral. But it's the same idea on having the f of c on one side. That's it. Bye.